Let's look into this question. A diagram is shown here and two forces are acting. First force is this and second force is this. Point A and B. This is the point A, this is the point B on a rod. So this is the rod lying here like this. The length is also given like this is the pivot point. So the B is having distance of 4 and the A is having a distance of 2 meter from the pivot. What they were asking is the moment of force we need to calculate. F1 about O. So F1 about O will be just multiplication of this. And then they have asked the moment of force F2 about O. This is the F2. F2O will be multiplied by this. So it will be 12. And then they are asking the total moment of two forces about O. So whenever we want to add the moment of forces, we need to consider the signs, or we have to consider the direction. It is clockwise movement or anti-clockwise movement. That way, if we see solving it, we will see the movement due to this force will be 5 into 2, 10 Newton meter anti-clockwise, and for this it will be 3 into 4, 12 Newton meter clockwise. Now for the third, we need to consider the signs. So the total net movement will be the algebraic sum. So algebraic means we have to take care of the signs. We have to take care if it is anti-clockwise, we have to consider it positive. If it is clockwise, then we will say it is negative. So we'll take sum accordingly. So the total movement will be the positive 12. So because it was anti-clockwise, so I've taken it positive here, and then a negative 12 because this was clockwise. This is by convention. So we'll get minus 2 Newton meter. So if you don't want negative sign here, you have to mention the clockwise direction then. So this negative sign is just saying that 2 Newton meter is a total moment and it is towards the clockwise direction. So like for example, if you leave this like this, these forces you will apply, you will get the net movement towards this, or this whole bar will rotate like this. It will go in the clockwise direction because there is a net movement about that direction. Now let's see. Two forces, each of magnitude 10 Newton, act vertically upwards and downwards respectively at two ends A and B of a uniform rod of length 4 meter. This is the 4 meter, 10 Newton and 10 Newton, and which is pivoted at its midpoint. Here it is pivoted. As shown in figure, determine the magnitude and the resultant moment of the force is about the point O. Okay, so we need to calculate. It is just a case of couple. See here, two equal opposite forces are acting on a body which are not in line. There is a separation between their line of forces. This force's line of action will be this, and this force's line of action will be this. So they are not acting on the same line. So it is a case of a couple. A couple is acting on the rod. And for that, we have state of a formula. We have to calculate we should know the magnitude of either force, which is 10 Newton, and then multiply the D. And remember, the D is the distance between the lines of forces. So here the distance between lines of forces is of 4 meter. So the torque will be 10 into 4, 40 Newton meter. And direction will be, see, by common sense, we can say it will rotate like this in the clockwise direction. So the direction will be 40 Newton meter clockwise, or you can say minus 40 Newton meter if you want to use the conventions. Now, if you are not using it, this question, attempting this question as a couple case, so you can individually calculate the moments about this point. So I will calculate about this point, and about this point due to this force, it will be 10 Newton into 2 because see the distance is 2 meter now because it is a midpoint. So 10 into 2, the direction will be minus 20, right? The movement will be minus 20 Newton meter. So here it is, I've done the calculation, minus 10 into 2. And then what about this? This will also rotate about this point. The rotation will be clockwise. So it will be also taken negative. So it will be minus 10 into 2. Again, minus 10 into 2, minus 10 into 2 will be the minus 40 Newton meter. Or if we want to show the negative sign, we will say 40 Newton meter clockwise direction. So we'll get the same answer even if you are going with the individual forces or you are working with it as a couple. But remember, what is the difference? If we are considering this as a couple, this D is the distance between line of forces. But if you are considering it as individual forces case, like this, then we have to take the distance from the pivot. So that is the major distinction. We should be very clear about it. So there should be no confusion while we are attempting these questions. Okay, let's see the next question. Here is the diagram. Two forces, each of magnitude 10 Newton, acting at point A and B in separation of 50 centimeter in opposite direction. Calculate the resultant moment of two forces about the point A, B, and O. So this is the A point, this is the B point, and sorry, this is the B point, and this is the O point, and we have to calculate moment about each of them. So let's start with the point A. So I want this diagram to be here. Let's see. So about A, what will happen? This force will not contribute to any moment because this force is passing through the pivot itself. And whenever that happens, that force is redundant. It will not create any moment because the distance from the pivot is zero. So D is zero, then our torque or moment is also zero. So in this case, when we are calculating about movement about A, then this force is redundant. Only this force will create movement which will be in this direction, clockwise direction. So we can say 10 into the distance. We can take it as 0.5 meter if we want to go for SI units. You need to convert centimeters to meters. So it will be 10 into 0.5, which will be 5 Newton meter in the clockwise direction. Okay, so here is what's the explanation. Torque due to left was 0, and for the right side force, it was 5 Newton meter clockwise or minus 5 Newton meter, you can tell. So the net will be the sum of that 0 plus 5 is 5. What about point B? Let's go for the diagram again. So what about across the point B? Now the similar thing will happen. This force will be redundant. It will not create any movement. Only this force will create, and we have to see how much distance between the pivot because we are considering about this point. So this point is a pivot. So that is the distance we have to take this distance. So this is already given 0.5. It will create the same amount of torque and direction also. If you see, that will be also in a clockwise direction. So we are getting the same answer. So what will happen when we are pivoting on this point O, then both will come into the play. And this is the case actually of a couple. So two equal and opposite forces with a separation distance given. So either force we have to take and the distance between these forces, and again we will get the 5 Newton meter as answer. So this is the explanation of that. So about point O, so we will take case of a couple and we multiply by 10 into 0.5, 5 Newton meter clockwise. Okay, and if you don't want to go for as a couple, you can calculate individually. So this is what I have done, 10 into 0.25. Why? When we are taking individually, we have to take the distance from the pivot. So if it is total distance is 0.5. Okay, so the distance from this force to this pivot will be 0.25. Or if it is 50 centimeter, it has to be 25 centimeter because it's the midpoint. So that's how we can calculate the individual forces. With individual forces we can also calculate the moments and then add them up. You will get the same answer as we were getting in the case of couple.